All right, welcome to another episode of this little series that I got going on, Line Academy. This is just a little bit of math help for my math class, but anyone else is welcome to join along. Today we're going to be looking over all of our um, over the entire unit of trig functions, inverse trig functions, yada yada yada, all that jazz. And I'll be going over the review guide that we were given in class. Um, so go ahead and follow along if you have that. We'll go ahead and start off with number 1, where we are given y is equal to -5 sine 2x minus pi over 3 plus 4. And we are asked to find a, b, c, and d, as well as our oops, amplitude, period, phase shift, I'll just abbreviate that, and our vertical shift, and I'll abbreviate that as well. So first, our a is going to be -5, b is equal to 2, c is equal to -pi over 3, and then d is equal to 4. Our amplitude is just the absolute value of a, so that is going to equal 5. Our period is going to be 2 pi over b, so that is going to equal 2 pi over 2. 2's cross out. We are given b, or pi, I mean. Phase shift is c over b. Sorry, c over b. So that is going to be negative pi over 3 over 2. That is just going to be equal to, let's see, that down, negative pi over 6. Sorry, once again. Um, just want to make sure that's right. Pi over 3 times 1 over 2. Yeah, those make 6. That makes pi, so that's going to be negative pi over 6. And then as for our vertical shift, that is just going to equal d, which is equal to 4. There are our answers. And that is it for number 1. Now let me go ahead and create a new blank page for us to look at. We're going to look at number 3 now, because I don't want to look at number 2. Number 2 looks like hell. So we are given cosine with a being greater than 0 and c being greater than or equal to 0. So let's go ahead and draw our graph. I'm going to have something like that. Starting at 4, going down to 1, going up to 7. Midline is at 4. We have another line at 1. And then let's go to put another line at 7. And I just put line or dotted lines there to make it easier to draw the graph. So we're also given the points. Let's go ahead and put 4 pi right here. 4 pi. In the middle here is going to be 2 pi. Pi is right here. And 3 pi is right here. Pi over 2. 3 pi over 2. 5 pi over 2. And lastly, 7 pi over 2. So let's go ahead, draw this out. We are going to be starting down here at 1, meaning let's go ahead and write down our values, A, B, C, and D. So our amplitude is between 4 and 7, 4 and 1. That's going to be 3. And we're also going to be starting, or actually, let's just go ahead and put down 3 for now because we don't know, um, or I guess A does have to be greater than 0. So there is no negative here, meaning we're probably going to have a phase shift somewhere in this graph. So here, pi over 2, intersecting there, going up to pi, point there, back down, 4, pi over 2. Then we can just follow this pattern. And lastly, it'll finish off right there. Go ahead and draw this. I have to be a little slower here because my hands are really shaky on this drawing pad. Yeah, that'll do. Alright, and then of course there's going to be arrows here and here. That'll have to do. So our amplitude is 3, meaning it's going to be positive. We're going to have from the looks of it, a sine wave. No, it has to be cosine. So if our amplitude is that, then we're just moving over by pi. So our phase shift is equal to pi. And from the looks of it, our period is going to be 2 pi. Um, we have a vertical shift of, let's see, vertical shift would start at 1, an amplitude of 3. So, yeah, we would have a vertical shift of 4. Period is 2 pi, so that means b is going to equal 1. And since it's pi to the right, c is going to equal negative pi. And because our vertical shift is 4 up, because of this 0 line here, d is going to equal to 4. And that means our equation is going to be something like, I'll write it down here, y is equal to 3 cosine x minus pi plus 4. That's it. Go ahead and go on to the Now these are a lot of graphing, or a lot of graphs. I'll go ahead and look at number 5 here. 5, y is equal to 3 sine 2x minus pi minus 1. Go ahead and write down a quick little graph. Good one. There we go. It's decent. Nope. There we go. All right, I like that. So we know our amplitude is going to equal 3. Our period is going to equal pi because of this, or because of this too right here. Phase shift is going to be pi over 2. Because again, that's c over b. That's going to be pi over 2. And then our vertical shift is equal to, oh, this phase shift is to the right, by the way. And then this vertical shift is going to be 1 down. So let's go ahead and draw our regular sine graph. Actually, we'll go ahead and write down our um, periods first. So I'll put pi here. We know, or we're not going to phase shift just yet. So we have pi over 2, pi over 4, 3 pi over 4, and these are going to be um, our base points. It's going to go up at pi over 4, intercept at pi over 2, go down at 3 pi over 4, and then up to pi. Now we just need to add a pi over 2 to all of this. So from 0, we're going to be starting at pi over 2, and then 3 pi over 4, adding that, we're adding a pi over 2 to that. Actually, wait. Yep. If we just go to the pi over 2, so it's going to be pi over 2 to the right. We aren't going to have really anything weird. So we can do 3 pi over 4 as one of our next points. This is going to be, let's go ahead and write down -1, amplitude is 3, so this is going to be 2. And down here is going to be -4. So pi over 2, we're going to be going up to 3 pi over 4. And then we're going to be going down to pi. And then we're going to be extending this to 5 pi over 4. We're going to be going down, -4. This is our next point. And then we'll have to extend this graph just a little bit more to get to that final point of 3 pi over 2. And this is going to be where our last point is. We can also go down to pi over 4, or over to pi over 4, down to -4, and then back up to -1 here. Now that we have the graph like that, we can draw it out. It's kind of awful looking, but it'll have to do. Yeah, it doesn't hit the point exactly, but it'll work. You get the idea. Now, how I got these is um, you take what would have been the base intercept and add 2. So I'll do down here. 0 plus pi over 2 is just going to equal pi over 2. And then um, pi over 2 plus pi over 2 is going to equal, whoa, yep, is going to equal 2 pi over 2. 2's cancel out. You just get pi. And then you take pi, add a pi over 2, and that is equal to 3 pi over 2. And that's really it. These are your intercepts, and then you take what's ever between them. So our first in-betweens were pi over 4, so you'd add, or so you'd have pi over 4 plus pi over 2. This can be rewritten as 2 pi over 4, which is just going to be um, or which is going to equal 3 pi over 4, which is our maximum right here. And that is really it for that graph. I'll do another one of the reciprocal functions, or the reciprocal trig functions, such as tangent, cotangent, and cosecant. Go ahead and do number 7. 7, we are given -4 cosecant. That's minus pi over 4. We are asked to find, or let's go ahead, write down our graphs, or put down our graph, I mean. That should be long enough. Is equal to, there we go. A is going to equal to -4. X, or B is equal to 1. And C is equal to negative pi over 4. And we don't have a D. D is just equal to 0. So our period is going to be 2 pi. I'm just going to go ahead and do all this. 3 pi over 2. Quick, simple trick is to just write down or is to put down your dotted line graph wherever. So since it's cosecant, that is the reciprocal of sine. And since it is -4, we're going to be starting, of course, at 0 and going down. So we'll have a point at 4, point at pi, point at 3 pi over 2, and point at 2 pi. Now you can really just use these points right off the bat here. We have um, whenever, or we're going to have asymptotes at whenever sine is equal to 0. So we're going to have asymptotes at pi. And 2 pi. Oops. And of course, there's probably going to be an asymptote over here somewhere along 0. But now that we have our points here, we can just draw the graph right off the bat. That was awful. Let me try that again. Goodness gracious, I cannot draw this graph for the life of me. There we go. And these are going towards positive infinity, but it's never reaching pi or 2 pi or 0 here. And if they ask you for the domain, it is going to be, what is that going to be? All real numbers of k pi, or wait, no, all real numbers except x cannot equal k pi, and k is an integer, and that's really it. And then range is going to be your range can be written down as negative infinity to -4 union, whoops, union 4 comma infinity. And that is it for number 7. Same thing can be done with a cotangent graph. Just plot down your points like you would for your sine or cosine graphs. And also the same thing can be done with tangent as well. Let's go ahead and go on to a new one. These ones I went over. Number 8 you should be able to do pretty easily. Ooh, that's kind of mean. Hmm. Hmm. Okay. Yeah, let's go ahead and look at number 8. If we look at it, we are given the equation h. Whatever, I'll just do that. H is equal to 15 plus 7.5 cosine 2 pi t minus 3 over 12. This can be rewritten as 7.5 cosine 2 pi over 12 multiplied by t minus 3 plus 15. A is equal to 7.5. B is equal to 2 pi for 12. C is equal to -3. And D is equal to 15. That means our amplitude is going to equal 7.5 period is going to equal 12. How did I get that? 2 pi over 2 pi over 12. Flip that. 2 pi over 1 times 2 pi. Nope, whoops. 12 over 2 pi. These cancel out, you get 12. And then for our phase shift, since this is in parentheses, we're just going to go 3 to the right. and then we're going to go 15 up for the vertical shift. So let's go ahead and write down our parts. So part 1 is going to be part A on your sheets. How long is the cycle? So that would be 12, or by itself it would be 12 since our period is 12. However, we have to add on the 7.5. Nope, I am wrong. We do not need to add on that 7.5. We need to add on this 3 since our phase shift is 3 to the right. So how long is the cycle? Um, it is going to equal, well, 15. 15, um, 15 hours, we'll say. 15 hours. And then how high, or this is how long it takes to go through the entire tide cycle. And then part 2, how high at high tide. How high at high tide. That is going to be equal to, well, we have 15 plus 7.5. That is going to be 22.5. And that is going to be in feet. And for our last one, how low at low tide. That is going to equal, well, let's see, going up 15, amplitude is 7.5, so 15 minus 7.5 would be 7.5, I believe. Yep. And that is it for number 8. Go ahead and throw up a new thing, and I'll run through 9, 10, and 11 because 12, 13, and 14 are really easy to do on your calculators. So 9 we went over these before. It's just the inverse trig functions. Tangent of -1. So what does tangent, or what does x need to be in tangent to equal -1? If we look at our, go ahead and draw the unit circle back over here. If we look at our unit circle, cosine is positive here, all of them are positive here, sine is positive here, and tangent is positive here. For this, our domain is going to be negative pi over 2, and pi over 2. So it's going to be between uh, quadrant 1 and quadrant 4. Since it's negative, it's going to be in quadrant 4. Now what makes tangent 1? That is going to be pi over 4. However, we cannot have 7 pi over 4 because that's not within our parameters, so we have to go back 1, which would give us x is equal to negative pi over 4. So tangent, inverse tangent, -1 is equal to negative pi over 4. let's go ahead and look at number 10, where we have inverse sine of 3 root 3 over 2. Our parameters for this is negative pi over 2, greater than or equal to what does sine of x need to be to equal root 3 over 2? This is going to be between quadrant 1 and quadrant 4. So x needs to equal pi over 3, meaning inverse sine of root 3 over 2 is going to equal pi over 3. Let's go ahead and move on to number 11. 11 is inverse cosine of negative 1/2. Our parameters for cosine is going to be from has to be greater than 0, greater than or equal to 0, but greater than or equal or less than or equal to pi. These are our parameters, that is between all this. Now we see that it is 1/2, so what may or would what x do we need to make a negative 1/2? X would have to be, I believe, negative 2, nope, 2 pi over 3. It would just have, x would just have to be 2 pi over 3. Because it's not quite pi, but it's still in here. So it would have to be 2 pi over 3, meaning that the inverse of cosine of negative 1 over 2 is equal to 2 pi over 3. And how did I do this without just looking at a calculator or looking at a unit circle? I don't have my unit circle with me right now. I just memorized this table, sine, cosine, tangent. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Oops. There we go. Sine of 0 is just 0, and then it starts going up from here. 1 over 2, root 2 over 2, root 3 over 2, and then 1. And then for cosine, it is the complete opposite, so it's going to be 1, root 3 over 2, root 2 over 2, 1 over 2, and 0. Tangent is a little bit more different. At 0, it is 0. At 30 degrees, it is root 3 over 3. 45 degrees, it is 1. At 60 degrees, it is root 3. And then at 90 degrees, it is undefined. If you memorize this table, a lot of trigonometry becomes really, really easy to understand, and you can do a majority of it in your head. Anyway, on to the next one. We are going to be looking at domain and range for each function and the inverse of each trig function, except except cosecant, secant, and cotangent. So 15 sine, our domain for sine is all real numbers. Our range is from -1 to 1. 16 cosine, same thing. Domain is all real numbers. Range is -1 to 1. 17 tangent. This one is a little bit different. Domain is actually going to be all real numbers. That's horrible. All real numbers, except x cannot equal k pi, where k is an integer. Let's go ahead and go on to 18, which is arcsine. This one is a little bit more different. Domain for arcsine, if you have your calculator with you, down inverse sine of x. I have to change my values here, goodness gracious. It's a little bit of a problem. Our domain should be, if I remember correctly, it's going to be from -1 to 1. And then our range is going to be from -pi/2 to pi/2. Whoops. So what you're doing with arcsine is, let's go ahead and just draw a quick, tiny little graph here. Goes through 0, and it's down here. What you're doing is you're just taking away what's left of the sine graph, and you're just leaving the middle part. So that'd be from pi/2. Whoops, nope, messed that up. Oh, I messed this up big time. Domain is pi/2, or -pi/2, to pi/2, and then our range is from -1 to 1. Now, why is that? Well, because we have pi/2 right here, -pi/2 right here, and then we have +1 here, and we have -1 right here. And that's about it for arc sine. Same thing for arc cosine, but it's a little bit more different. So 19 cosine. Whoops, is that right? Yeah, arc cosine. Our domain this time is going to be from 0 to pi, and then our range is going to be from -1 to 1. That's about it for that. If you go ahead and draw a tiny little graph, you'll see that this intercepts at pi over 2, ends at pi, starts at 0, go down there, and then we have our little dotted graph and whatever. So we only get pi and 0, which is where we get our domain, and then it's 1 and -1. Now we're going to look at number 20, which is arc tangent. Oops, I completely forgot the range for this one. Range for this is all real numbers. Wait, yep, range for this is all real numbers. That's from -infinity to +infinity. Arctangent domain is going to be from -infinity to +infinity. Range is going to be -1 to 1. Not too complicated until you see the graph. Until you see the graph. It's always the graph. We have 0 here. Now the funny thing with this one, hold on, did I do this right? I'm positive I did this right. Yep. So with this one, tangent was basically just rotated 90 degrees. So you're going up this way and back there, and you're going down this way, and you're going back down there. Originally, it would be something like that. And that is really it for the entire review packet.